So this one's pretty different, similar kind of function. We have a square in there, and we have an alien baby throwing a ball up in the air with an initial speed of 35 feet per second. I doubt aliens use feet. That's okay. We'll go with it anyway. And then we want to find the average velocity. So this one's pretty similar. The difference here is we want to find the average velocity for the time period. So they're not giving me x values necessarily here. They're giving me a change in time from 2 seconds. So I'm going to make a little table for this to kind of explain. If we read the fine print there, we have multiple things going on here. We have time in seconds. We have position, or actually this is height to be more specific. And we are also looking at velocity, v. And we are starting with t equals 2, and then we're finding the average velocity for the time period. So these right here are changes in time. Change in time. So that fine print is important. So that means this is really a delta t. And we're finding velocity, and average velocity is change in height divided by change in time. So they're not actually giving me the x value, they're giving me the denominator of my slope here. So if t starts at 2, we'll calculate that height in a moment on a calculator. Then the next one would be 2.01, right? Change that much time later. And then the next one after that is 2.005. Next one after that is 2.002, and then 2.001. So we want to find the heights at each time and the velocities. So again, quick way to do that is just use function notation on a calculator. So we have 35t minus 19t squared. Your numbers may be a little bit different. And let's just redo this. All right, so I'm going to call this h of x. Desmos appreciates x's. Don't think it does t's, but I'm just going to use x. And I have 35x minus 19x squared. So that is the graph here. And, oh, interesting, 2 seconds later, it happens to hit the ground. And so we're going to try and find the speed at which it hits the ground. Now, I don't actually really care about the heights. I just want the slopes, right? So the problem I have here is just asking me to find the average velocity, which is my slope here. So that means I'm going to use my function h. I'm going to plug in my time 2 minus h, and time 1 is always 2. And then in the denominator, it's whatever delta t is. And my delta t is either going to be 0.01 or 0.005 or 0.002 or 0.001. And my t2s are always going to be 2 plus whatever value of delta t I'm using, right? 2 plus 0.01, 2 plus 0.005. And so this is the way I'm going to enter it into my calculator, sort of. We'll see. All right, so slopes, we set up a fraction first, and then I want h of 2, and then I'm going to put a plus, and then my first change in time is 0.01. And then I want to subtract from that h of 2. That's my numerator. Double check my notes. All right, my t2 is always 2 plus the change in time, minus the height at 2 seconds in. In the denominator, it would be 2 minus 2 plus that, which is just that delta t there. So that would be 0.01 in this case. And I get a slope there of negative 41.19. And if we think about this graph right here, it's coming down, definitely a negative slope coming down there. So 41.19 is the first calculation. Negative 41 for my version. And then we just keep repeating that. The next one was 0.005, 0.005, adjust the bottom two, and I get negative 41.095. And then we just keep, so these values here are getting closer to 2, right? This second group here. Closer to 2 as we move in that direction. So the next one was 0.002, change both values. Negative 41.038. Change to a pencil, please. So my guess, and I'm just going to put it here right now, is negative 41, but maybe there's some more decimals there. So the next one, 0.001, negative 41.019. And I'm going to do a couple more just to improve my guess. Negative 41.019. So they are heading toward negative 41, but maybe it's more like negative 41.1. How do we really know for sure? So I'm just gonna, put another 0 here and here. 0.0019, put another 0 there and there. Yeah, I'm guessing that this is probably heading toward negative 41. That's my guess. Oops, wrong button. Yeah, that's what I'm going to put as my guess there. And yours is going to be a little bit different. Now, I didn't really need to fill out this table here because my calculator was doing it for me. So I didn't actually need to know the heights because I can just calculate the slope all in one shot on my calculator. And we do want to learn to use our calculators to our best ability. And this avoids any rounding errors. So I wouldn't do this in multiple steps where you calculate h of 2.01, and then you then do your subtractions. Don't do this in multiple steps. Use your calculator smart. Do it in one step if you can. No rounding error. Let's try another one.